This week, we speak once again with Cesar Rodriguez from Accurix about maintaining immutable systems so misconfigurations don't menace them. In the news segment, bugs bag higher bounties for Microsoft. Client encryption doesn't go so well for S3. Software dependencies chain themselves to languages. Ambiguity sends an unwelcome message, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Today, cybercriminals are taking advantage of an expanded attack surface to commit malicious activities ranging from hijacking user accounts to making fraudulent purchases. Businesses need solutions that can protect their sites from this increase in fraudulent activity. reCAPTCHA Enterprise is a frictionless fraud detection service that leverages our experience from more than a decade of defending the internet with reCAPTCHA and data for our network of 4 million sites. To learn more about how reCAPTCHA can defend your website or mobile application against fraudulent activity, visit securityweekly.com/reCAPTCHA. Security threats in cloud-native environments move fast, which means that security teams need to have the same visibility into their infrastructure, network, and applications as developers and operations. With Datadog security monitoring, engineering teams can easily detect malicious activity in real time before it affects their customers. Use out-of-the-box detection rules and detailed observability data in one unified platform to investigate security attacks. See it in action by signing up for a live security demo and receive a Datadog t-shirt by visiting securityweekly.com/Datadog. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/Synopsys to learn more.
Welcome to Application Security Weekly. This is episode 118, recorded August 17th, 2020. I'm your host, Mike Shima. I'm here with Matt Alderman. Hello, Matt.
Good morning, Mike. We're back on schedule again. Been a couple weeks.
We're back on schedule. Yeah, it gave you a week breather, I think, a little bit, too, to recover from summer camp.
Yeah, definitely. We needed it, too.
That was a lot of interviews, a lot of content that came out from the entire Security Weekly network. So if you haven't watched it or listened to any of it or all of it yet, you still have time. Go check it out. But also want to make sure you have time to listen to Mr. John Kinsella, who we have with us as well. Hello, John.
Howdy. There was a lot of really great content in all that stuff from that Black Hat week. So definitely go back and check out what we covered in there. But hey, Mike, good to see you. Hope you're doing well.
Doing well here, surviving an electrifying weekend here in San Francisco. And speaking of things that are electrifying, you can also join the Security Weekly mailing list for webcasts and virtual training announcements, as well as to receive your personal invite to our Discord server, in which people are chatting right now. Visit securityweekly.com/subscribe and click the button to join the list. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by visiting securityweekly.com/guests and completing the form. We review suggestions monthly and we'll reach out to you once reviewed. Cesar is the head of developer advocacy at Accurix and has spent the last 10 plus years working in the cloud security space, securing both private cloud in the military industry and public cloud in the financial sector. He is passionate about contributing to the developer community through open source projects like Terascan and blogs and participating in local meetups. Hello again, Cesar. Thank you for joining us.
Hey, hello again, guys. Thank you for having me today.
Yeah, it's great. It's been, you were last on episode 112, way back at the end of June, which possibly not everyone listened to because John, I think, missed that particular one. So it's good that we have you here this time, John. And obviously, too, great that we have you here, Cesar, to talk about basically looking at what it should be an immutable deployment, immutable environment in cloud services. But when things are immutable and they are misconfigured, that's not necessarily the best combination. So perhaps let's start with a little bit to talk about, what should we be worried about as we're looking to cloud deployments and how in our infrastructure as code, and what can we do about protecting it?
Yeah, so so from our perspective, what we think is the best and safest approach to maintain your cloud environment is using something that we called immutable security, which means that your source code, your infrastructure as code, is the source of truth of your environment. So to do that, we have three tenets. One is to secure your code. So making sure that you're applying security controls to your code as soon as someone is typing it, making sure that they get immediate feedback into what are the security issues, so you're not introducing risk into your environment. The next one is securing your cloud. So those same security controls that you're applying to your code, you need to make sure that you're monitoring your cloud environment so that if there's anything like break the glass where people are making changes to the cloud environment directly, or any other issue happens in your environment, you want to make sure that you're monitoring and remediating any issues in the cloud itself. And then the final tenet is eliminating security posture drift. So if someone made a change in your cloud environment, you want to make sure that that change is reflected back into your code if it is a positive change, like if you fix a security issue in the cloud directly. And at the same time, if someone made a change that shouldn't be part of your cloud environment, you want to make sure that your code is always reflecting the source of truth. So you want to apply those changes. So making sure that the immutability of your code is retained as much as possible.
Cesar, we talk a lot about immutable infrastructure in the cloud. And I think you point out some very interesting challenges that if you are allowed to make changes in production to the cloud environment configuration, you lost that immutability, because now you've got a change that's not reflected back in your original templates. And so if something happens and I have to bring that infrastructure back up, I now have a gap from what was in the code to what is now running. So how does that loop get closed in an efficient way? Because I think that's a challenge for a lot of organizations.
Yep, and that's what I'm going to demonstrate today, showing you how we can capture your issues, your drift in your cloud environment, and showing you how that maps back to your infrastructure as code, and then how can you remediate any issues, how can you bring back your infrastructure in the cloud to the reality of your source of truth, which is your code. So I'll show that to you today.
Great. What a setup question, I guess.
Yep.
Yeah, and I think too, maybe as you're getting ready to give us a demo to walk through in the spirit of show don't tell, I think too one of the things to emphasize here is, yes, drift can happen, because you also mentioned there in the very beginning that perhaps there are some positive changes that need to be made, but anytime humans are mucking about with the production systems, even those positive changes can get forgotten. So there does need to be this feedback loop about, here is a drift that happened, and either you want to capture it or reject that drift. But you also, I guess part of my question is, who's capturing that, and how is that feedback coming back? Because one thing, if we're talking about vulnerabilities, it could be very common that here is the vulnerability work stream that opens a JIRA ticket or opens a ticket in some one of many single panes of glass that seem to crop up in systems. And so developers have to come find that there's a vuln, understand it, is this false positive or not, and then go fix something. So I guess I'm trying to set you up with another sort of a question to answer here.
No, yeah. So that's the gap that we're trying to address. Having you, similar to the way that you capture vulnerabilities, having a similar way for you to know what are the vulnerabilities in your resources and what are the drift that have occurred from what your stated goals that you had in your code in your environment. So this is a high level picture of the demo that I'm going to show you today. It's very simple, but it's going to be very useful to show you what we can do. So at a high level, this is a VPC within AWS, and I have a couple of EC2 instances fronted by a load balancer. So there's three steps that I wanted to show you. I'm going to show you first how would this look like from a developer's perspective, what would they see in their desktop when they're deploying, configuring and deploying their infrastructure. Then I'm going to show you what does this look like in our UI. How do we capture the different violations and issues that occur. And I'm going to show you how this works within a pipeline, like your CI/CD environment. How do you enforce security controls there? And then finally, I'm going to show you how do we capture your cloud environment and the drift between your cloud environment and your infrastructure. So the first thing I wanted to show you is my IDE. And just walking you real quick through the different resources. So this is what I talked to you initially about. We have a couple of EC2 instances, and these just have
one thing real quick, Cesar, as we walk through this, remember a lot of our listeners on a podcast. So try to describe a little bit of what you've got on the screen.
Yeah, exactly. Yeah, so I'm just showing you a Terraform of an EC2 instance that has a user data script that installs Apache and just echoes some text to an index.html file. So very simple. And we also have a load balancer that is in front of those two EC2 instances, is listening on port 80, doing HTTP, and has a security group attached to it. And the security group currently has a private IP of my VPC CIDR blog, which is 10.0.0.0/16. And I also have a similar security group attached to the EC2 instances that is limited to my VPC CIDR. So the first tool that I wanted to walk you through is our open source static code analyzer for infrastructure as code. It's called Terascan. Today we released, coincidentally, version 1.0 of Terascan. And our goals with this tool is to make it a generic static code analyzer for infrastructure as code. So it will be able to scan Terraform, CloudFormation, Kubernetes YAML files. And at the same time, we are applying policies in a cloud agnostic way. So right now it supports AWS, Azure, and GCP, and we'll keep adding policies to that. So real quick, I'm gonna show you what Terascan looks like. So I'm just running the Terascan command and looking at the issues that it found. And for this particular configuration, it found a couple of issues. One is that on my VPC, I don't have flow logs enabled. And it's definitely a security issue because we want to make sure that we have observability of your network environment. So the other issue is that the ELB load balancing protocol is not secure. I'm using port 80 on the load balancer. It doesn't have SSL or anything enabled. So this is Terascan. So I'm gonna show you real quick how would this work in a CI/CD pipeline with my GitHub repository. So I'm gonna introduce an additional weakness here. I'm gonna make the web instances and the load balancer publicly exposed. And now I'm gonna use our Accurate CLI, which is a wrapper around Terraform, and executing a Terraform plan with my Accurate CLI. And this is similar to Terascan. Terascan is more of a linting tool. It doesn't need access to your Terraform plan, but our Accurate CLI does more of a deeper analysis and knows the values of the variables that you're putting into this environment. So automatically it generates a report that's telling me that I have 5 low issues, 6 mediums, and 6 highs. And it put an HTML file here on my IDE. So I'm gonna open that real quick. And let's see. I'm gonna scroll down to the high issues because I'm looking for the change that I just made, which is these 2 issues saying that we have security groups that is open to the internet. So very common security issue. So now I'm gonna go ahead. Oh, and by the way, I have the load balancer here open. So this is what it looks like. It's open to the public internet. And this is one of the instances which is also open to the internet. So now I'm going
I
to go
think there
ahead.
too, one of the things to really emphasize is that you just did that. You could get that security feedback without even having to deploy it, because I think, it's kind of maybe
Yeah,
to
exactly.
restate the obvious, but to be extra clear about it, this is that code analysis, because that's what the infrastructure is going to look like when it's deployed. But you did all that analysis in the IDE, so now the developer can save themselves from pushing that vuln out to production and then fix it right now in code before it does go live.
Exactly. Yeah. And that's one of the first tenets, making sure that you apply your security controls in the code itself so that you avoid issues going into your cloud environment.
So Cesar, let me just validate two simple things here that you just did. Number one, from the IDE, you're looking for potential weaknesses in the infrastructure as code as you're kind of typing and putting some of the stuff into the IDE. Then, as part of a check that you would do as maybe part of your build process, you ran the CLI tool that does a deeper inspection because it understands some of the other dependencies that are in that code and pulling out potential vulnerabilities, right? That's kind of the two steps in a nutshell you just showed us, right?
Yep. And
Yeah,
so
okay.
I'm going to show you now. So this was all within my computer. Now I'm going to show you how this works in GitHub itself. So I have a GitHub action that is using the same Acrix CLI and will analyze the code as I'm pushing it into my pipeline. So if you employ governance in your CI/CD pipelines, you can use this tool to enforce that governance. So I'll show you that real quick. Let me go to my GitHub, and I just pushed the code. And we're going to go to GitHub Actions. And this is the one that I just pushed 43 seconds ago. And if we go here, we'll see I have it set to fail if I have high findings, and these security groups issues are high findings. So it's failing because I have those high findings.
Right. So you're just setting up basic policies to validate against when you're integrating that in. And if any of those policies fail, you're flagging them here.
Exactly. And this is similar to the output that you saw on my desktop. Now you're seeing it in GitHub. And then the other important thing here from a governance standpoint is that when you're using this Acrix CLI, all the results get pushed into our UI. So you can capture the results of the different distributed repositories that you're trying to scan in your environment, and you can see them here in your UI. So this is similar to what I show from my desktop. Now you have a graphical representation showing you what are the different issues that were found. So there were 16 issues found. Let me show everything.
Yeah, so what you've shown us is that on the dev side of things, they don't need to leave the IDE, nor even need to leave the normal deployment pipeline that they're already used to. You pointed out here's how to hook up the CLI into GitHub Actions, and that feedback comes directly to developer, breaks the build, blocks the deployment. What you're showing us now is that would be an angle, for example, I'm going to imagine that's the security side that can come on, rather than look at the one particular app that's being worked on, could look at the entire ecosystem, all of the apps being deployed. So just different ways of aggregating this information.
Yep, exactly. This is the same aggregate view of what you saw in the developer environment. Now you have a graphical representation of the issues, and you can go deeper into each of them, and I'll show how do we go deeper into them once I set up my cloud environment. So let me show you how this looks in the cloud. And I have my cloud environment set up here already. So I pre-deployed the instances before we started the show. So real quick, this is what the two instances look like. And just going to the same issue that I was showing, if we go to the security groups, we see that these instances are exposed to the public internet. So I'm gonna run a scan here, making sure that the Acrix scans my cloud environment for any issues. And while that scan is running, I wanted to show you what are the policies that I have set up for this environment. We do all, and I'm filtering for AWS. And the one that I'm checking here is sys benchmark, which is a very common benchmark for cloud. We also have other things like GDPR, HIPAA, NYDFS, PCI DSS, SOC 2. So these are policies that are packaged together. So you can, if you're targeting a particular compliance or other type of requirement, you can do that here. Let's go back to the dashboard.
Your scan is running. I think it's also important to point out that this scan, it of course needs some privileged access in order to be able to read the information from the environment, so you get a clear picture and a complete picture. But it doesn't need to write to it. So it's we haven't yet seen, I think, how you would remediate perhaps some drift that might be coming up in a moment. But yeah,
I'll show you in a minute. So basically, it's a IAM role that's running in the cloud. In my AWS cloud environment, where I have this particular role only has read-only permissions.
Mm-hmm.
And that's all I need to be able to run these checks. So let me go to the cloud violations and let me show you what it found. So similarly, I found my security group issues where my instances are open to the internet. So, which is what I wanted to show you. So now I'm gonna introduce some drift into the environment. Let me first go to one of the resources real quick. So this is the resource view where you can see the different resources that were captured both by our code checks and our cloud checks. And you can filter here for which ones have violations. What are the violations that it had found? And what's the configuration for the issues? How does it map between what's in the cloud and what's in your infrastructure as code? The history of the changes between these two resources in the cloud and in your infrastructure as code. So I'm gonna go, this is the EC2, this is the host number 0. So I'm gonna introduce some changes here. Oops. So I'm just gonna change some networking settings.
Yeah, so basically what you're demonstrating now is that this is the manual drift that a human needs to come in and change something in the production environment.
And so what I did, I came to this screen which changing the source destination check for this instance, and just to demonstrate someone coming to your console and to your environment and doing a manual change. Oops, so let me go back to the Acrix console and I'm gonna rescan my environment. And then we're gonna see if the drift was detected. So while this is running, let me show you what are some of the integrations, and I'll come to this at the end. But basically, some of the ways that you can integrate the alerting that you pick up from here is you can set up a Jira ticket for someone to remediate something. You can configure Slack or email alerts, or you can configure your repository directly. And when you configure your repository, something that we can do is called remediation as code, which means we will make a pull request to your code with fixing the issue that was detected. So let's go back here and look at the drift.
So I think, yeah, we're looking to identify the drift that happened. The key thing you're showing us, at least for me, that stood out in the integrations, that you're moving to where the developers are working, which is a recurring theme we try to highlight here in each episode. Is rather than pull the developers into one particular new web page, we can actually push out to Jira, Slack, the repo, and not interrupt their typical where they work.
Exactly. And I think it's also very valuable when you can show them in code what the issue is and how to fix it rather than in words. So because a lot gets lost between security teams and dev teams when they don't really understand what's the issue and how to fix it. So I think it's a really powerful way of remediating security issues and making sure they don't keep happening over time. So this is the drift view, and from here we can see that there's two things that are missing from my infrastructure as code comparing to my cloud environment. And one is the user data in the cloud environment is detected as base 64 encoded. I have it on my ID set with just text. And then the other one is the one that I introduced manually, which is the source destination check, which is not active in my infrastructure as code. So the next thing that I wanted to show is doing that remediation as code. So if I go here to my security group violation that we were talking about earlier, you can either ignore this issue, you can escalate it, you can create a ticket, or you can create a pull request. So I'm going to go here to my pull request, and this is what we can do. I'm going to set this back up to my CIDR block, which is my VPC CIDR blocks of 10.0.0.0/16. I'm telling the title of my pull request will be, you have an HTTP open to the internet, HTTP port open to the internet. So we need to change this. I can preview the changes. So here's the change that's going to happen. 000 is going to be replaced by my VPC CIDR block, which is my private IP. And then I'm going to create the pull request. So in this view, now we can see my pull requests that have been open. I only have one right now. And if we click here, this environment is configured to my Bitbucket. And you can see that we open a pull request in the developer's repository, showing them exactly what they needed to fix so they can remediate this issue.
Right. So what we've seen is the idea that rather than just tell the developer, oh, don't open up this port to the internet, and this story ends there, then because the natural response is, okay, well, what should have been done? Then you could say, oh, well, just keep it close to your internal CIDR block. And say, okay, cool, I can just do that, and then figure out what the change is. Or you just say, actually, here is the Terraform, here's the YAML update, just click this, and this will actually both, and as I told you what the problem was, that is open to the internet, here's what the solution is, and as long as this solution isn't going to interfere with something else you've done, it's as easy as clicking on accept the, merge the pull request.
Exactly. Yep. So I know
I'm going to be a bad co-host for a second and give a bit of product feedback or a comment on this. So looking at that pull request and the diff there, is it possible to turn off formatting?
Yeah.
Or can I put that in as a feature request? Because since you're talking, I know what the change is going to be here, right? You're doing the 10/16, but otherwise I've got 1, 2, 3, 4 lines of code which should change, and it's basically just a format change. Yeah.
Yeah.
Some of us are persnickety
because
about
of the way that Terraform formats things. So
okay.
Yeah.
So I'll send the bug request over to Terraform.
Thank you.
Yes, but that's a good eye. Rather than arguing about white space and tabs, let's focus on what the actual change should be. Good call, John.
Definitely. Some people like to argue about white space. Yeah, so the final thing that I wanted to show you is that now that we have information about your cloud environment and about your code, what we can do as security experts is we can analyze what are the threats based on what we saw. So these are the threats. We have an HTTP open to the internet. VPC flow logs are not enabled. We can also visualize what will be the kill chain for these threats. So the HTTP open to the internet allows me to do some reconnaissance on your infrastructure. And it will also allow me to do delivery if you have other weaknesses that allow for that. And finally, what we can do is we can visualize how do these threats relate to each other in your environment and within your resources.
Interesting, because you know the interrelationship of all the different services running, both statically and dynamically.
Yeah.
You can understand the potential attack path and where it goes. So now if I have a threat but I also have known some other known misconfigurations or vulnerability, you can actually do some prediction about where the attack path or propagation could actually occur. That's
Exactly.
kind of what you're showing here, right?
Yep. And as security people, you want to focus your efforts on what are the threats that are going to be most impactful for your organization. And if you don't really know how is your environment interconnected, you're not going to have the information to make a good decision.
Yeah, and we've talked about this before, right, guys? I mean, if you think about it, as we build out these new microservice-based architectures, who really has visibility into the full application view, right? And here you are visualizing it for us, because I don't think many organizations know what that graph looks like.
Yeah, it's extremely difficult to measure what are the impact for any threats in your environment, especially on the microservices world where everything is interconnected and deployed separately.
I also like that idea of one. I think it's a lovely use. It looks like a D3JS force graph, which I think is always lovely to see in a UI. But with this more security oriented, it also seems that it'd be a great way to run pre-mortems in the sense of, here's a security team. We're going to introduce some artificial drift, or we're going to introduce a what if scenario and say, here is an IAM leak, or here is that port open to the internet. Then what would happen through there, both as you were describing in the kill chain, or the attack chain, what's going to be possible, and what kind of Matt was highlighting, what's the interdependency and interconnectivity between all these services, so that, sure, maybe one small misconfiguration doesn't seem particularly bad, but has a really consequential downstream mistake if you can point out, here is the data store, an S3 bucket or a GCS bucket, something like that, that has some pretty sensitive data in it.
Yeah, and then the other thing to highlight is, usually when you do threat modeling, you're doing it as a paper exercise. You don't really know how is that reflected in reality, into the reality of your environment. So having the information of what the architecture looks like and what each of the resources mean and the threats to those resources in a visualized way that is reflected in how your environment looks like today is really powerful for you to do more effective threat modeling.
I think so. I think at least half the time in threat modeling exercises I've been in are really just trying to draw out, well, what is the system we're talking about in the first place on a whiteboard? And then having the back and forth discussion like, oh, well, actually, this is connected here, or, oh, it also talks to this other service. So just saving the time for that. Yeah, exactly.
Yeah. Most of the time, you don't really know. You're just trusting that the knowledge that the people have is correct.
Yes. So having the confidence in the information, and that this is what your infrastructure either looks like or will look like once it's deployed, does really speak to me in that sense of being able to do those pre-mortems or those what if scenarios for threat modeling. I definitely like that. And I think the other thing too is I also like the idea that, drift from the very beginning, drift can happen, and this is the way to capture that positive drift so that the changes can be brought back into the remediation. And you're also highlighting, I'm jumping around a bit now, Terascan too, open source. Is there something more you could tell us about that, or what could someone go and use Terascan themselves with right now?
So right now today, what we release is we completely changed the architecture to be more general purpose. So today, right now, you'll be able to scan Terraform for AWS, GCP, and Azure. We're going to be quickly adding support for Kubernetes and CloudFormation.
Oh, that's awesome.
There.
Cool, thank you, and thank you for giving us this was a very good visual tour for one of our episodes. So I want to thank you for that, Cesar, and thank you for walking us through what it means to have immutable code that can actually be monitored for misconfigurations, and then more importantly, also fixed. So thanks for that.
Yeah, thank you for inviting me.
Also want to thank Matt and John for joining us as well. And for all those who've been following along, if you'd like to learn more about the Accurix platform, come visit securityweekly.com/Accurix, ACCURICS. With that said, we're going to take a quick break, and we'll return with news of the week.